Correlation is a statistical method used to determine whether a relationship between variables exists and what is the strength of the relationship. While regression is still a statistical method used to describe the nature of the relationship and especially the type of predictions that can be made. We'll be focusing mainly on simple correlation regression, when only two variables are under study. Generally, the variable x is called independent and the variable y is called dependent, and data generally are paired or come in pairs, an x and the corresponding y. Instance, we could study whether the weight at birth is related to the lifespan, or also we could look whether blood pressure is related to age. This is for simple correlation. For multiple correlation, we could look whether social background, IQ scores, and number of study hours are related to the GPA that the person achieved. The first thing we like to do in correlation regression is to draw a scatter diagram, also called scatterplot, which is simply a visual display of the relationship between the x variables, which is generally represented on the x-axis, and the corresponding y variable, which is generally represented on the y-axis. Generally, the independent variable is chosen as the one that can be controlled or manipulated. Linear relationship, as more recalled from the past, is generally represented by a line. The equation of the line in slope-intercept form is y equal mx plus b. Here is the graph of a line. M represents the slope or inclination of the line, and B represents the y-intercept. M, the slope, is generally rise over run. So in this little picture, if I take the points P and Q with coordinates x1, y1, and x2, y2, this is the rise, the delta y, the rise, and this is the run, the delta x, which can be given as y2 minus y1. This piece is y2 minus y1, and this piece is x2 minus x1, or the delta x. Let's do an example. Let's draw some scatter plots for the following data. Why are the scatter plots important? Because they give us a visual relationship, whether it seems to be a line of best fit through the data, or whether maybe it seems to be a parabolic or other kind of relationship. In correlation, we are generally looking for a linear relationship. So here are two examples. First, the number of absences and final grades of 7 randomly selected students from a stats class. And here are the absences between 6, 2, 15, 9, 12, 5, and 8 days, and then the corresponding final grades for those students. So these data are paired because they are taken on the same 7 students. So the first student had 6 days of absences and a final grade of 82, 2 days of absences and a final grade of 86, and so on and so forth. And the second relation between the number of cigarettes smoked per day and the age of the smoker. And this time the ages, the pairs are 27 and 6, 64 years and 10 cigarettes, 36 and 9, and so on and so forth. We are going to try to graph this data. Let's start with the first graph. Number of absences in this case is the independent variable. The number of absences corresponds a final grade. So in here, the first pair is 6 and 82. So in here, 6 goes with 82. So roughly, if I take my 6, I go all the way up. This is the first pair, 6 and 82. Another pair is 2 and 86. So starting at 2 and 86 is a little bit above. Third pair is 15 and 43. So 15 goes with 40, and between 40 and 50 is 40. Next pair is 9 and 74. So 9 goes all the way up to 70, 74 roughly here. And 12 goes with 58, so almost 60. This is 60, so 58 will be roughly here. And 5 goes with 90. So 5 goes with 90. And so there is a bit of scatter, and 8 goes with 78. So 78 will roughly be in here. So it seems to be a relationship that is quite linear. Like you can see a line. You can see that the line of best fit will probably go something like that. It's like we'll have to construct it better, but it seems to be sloping in this direction. So the scatter plot gives you an idea whether or not a linear relationship exists, and also in which direction. So in this case, it seems to be the less absences, the higher the final grade, the more absences, the lower the final grade. So this seems to be what we call a negative linear correlation. And in order to see the strength, we'll have to calculate the coefficient. We'll see in the next lecture. And the negative lays on the direction of the line, and also the fact that as a variable decreases, for instance the absences x, the grades, so the y, do the opposite and tend to increase. Let's look at the next graph. In here I have the age as my independent variable, because we can pick people in the sample with different ages, smokers of different ages, and then the number of cigarettes is sort of connected with the particular. So it's the same smoker, we look at the age and the number of cigarettes. So the first pair is 27 years and 6 cigarettes. So here is 5. So 27 years will be roughly here, and 6 cigarettes is roughly there. 64 and 10. So this is 70, so this is 64 and 10, seems to be roughly here. And 36 and 9. So this is 30, 35, 36 and 9. Seems to be right there. 42 and 18, so 42 and almost 20. That's another point. 31 and 7, so 20, 30, 31 and 7 will be roughly there. And 18 and 12. So 18 and 12 is roughly there. So in here, see, the points go all over the places. So this 53 and 5. 50, 53 and 5 is roughly here. 64 and 12, so 60. So next one is 58 and 3. So 50, 58 and 3. So I see points, I see a lot of scatter, 25 and 7. So 20, 25 and 7 is roughly here. So it doesn't follow any pattern, either increasing or decreasing pattern. The points are all over the places, and so basically in here there is gonna be no correlation, or at least a very weak one, and no specific pattern. So have sometimes there is a sort of relationship, but it could be a relationship that is non-linear. We are mostly looking for linear relationship. What I mean is sometimes a relationship could be, like sort of this type, which seems to suggest sort of a parabolic relationship, but this is gonna be a non-linear relationship. In correlation, we mostly look for linear relationships. Thanks for listening, and look for more on the same topic.